Okay, good day. So our next video about mechanics and hydromechanics will be topic 11, Reynolds number. So what is Reynolds number? So differentiate the three regimes of Reynolds number first. So there are three types of flow. These are the laminar flow, the transition flow, and the turbulent flow. So as you can see, laminar flow is a type of flow of fluid which is smooth. So there are no waves or erratic movements of the fluid along the path. So that is laminar flow. While on the third one, so this is the laminar flow. Okay. While on the third one, we have the turbulent flow. In the turbulent flow, so the fluid will be moving in different motions, moving from left to right, up and down. So there will be erratic movement of the fluid. So that is turbulent flow. And then in between of the laminar flow and the turbulent flow, we have transitional flow, in which the flow is somewhat smooth, but there are little turbulence also. So it's between laminar and turbulent flow. And then if to determine how the difference of them, so we will have to use the Reynolds number. So Reynolds number, RE, if the Reynolds number is less than 2000, then that flow will be called laminar flow. If the Reynolds number is more than 4000, so it will be turbulent flow. But if it's in between 2000 to 4000, the Reynolds number, then it will be considered as a transitional flow. So that is the difference of the three types of flow. Okay, so this is the formula for Reynolds number. It is density times average velocity times the diameter of the pipe over the dynamic viscosity, which is also equals to the average velocity times the diameter over the kinematic viscosity. Okay. So explain the three regimes of dense in terms of their flow. So as you can see, laminar flow is smooth. Transitional flow is almost in between of that laminar and turbulent flow, while the turbulent flow is very erratic. The movement of flow. Okay, so this is turbulent, this is transitional, and this is laminar, the third one. Okay, so what is the difference? First, the difference first is the Reynolds number. So laminar flow has less than 2000 of Reynolds number. So Reynolds number has no unit. So the flow is smooth and orderly. So fluid particles move in parallel layers with little to no mixing between layers. So the flow is characterized by predictable and steady movement with minimal turbulence. And laminar flow is common in low velocity, viscous fluids, and is typically observed in small pipes or at low flow rates. So if you want to increase the flow, maybe the flow will also change. Next, we have the transitional flow, which is in between 2000 to 4000 Reynolds number or Reynolds. So in this regime, the flow behavior is unstable and can transition between laminar and turbulent flow. So since it is between, so maybe it will transition to laminar, or it will transition to turbulent flow. So it is in between those two. So flow patterns may vary with intermittent eddies or vortices present in the fluid motion. So the transition from laminar to turbulent flow can be influenced by factors such as velocity, viscosity, and pipe geometry. Okay. Thirdly, so we have the turbulent flow, which occurs at Reynolds numbers more than 4000. So in turbulent flow, the fluid motion is chaotic with random fluctuations and vortices present throughout the flow field. So there are very heavy eddies. So eddies is like a vortices or chaotic flow of fluid. So mixing between fluid layers is significant, leading to increased momentum transport and energy dissipation. So turbulent flow is commonly observed in high velocity flows, large pipes, and situations where there is a high Reynolds number. So that's it. So that is all for the Reynolds number. So there are three types of Reynolds number. We have the laminar, which is smooth, the transitional, which is around between smooth and or chaotic, and then the third one is the turbulent flow, which is very chaotic. Okay, so we will use this on our next topic. These ideas will be used on our next topic. Okay, so I hope you have learned something. Share this video to your friends, to your classmates, and to all other marine engineering apprentices or cadets. And I hope to see you on our next video. Please like, subscribe, comment if you have any comments. So, and see you on our next video. Thank you very much and God bless.